Length. When you measure something, will something's length ever be negative?
Yes.
Hopefully not.
How?
Because, like, if your belly button not out, it's in, so that means it's a negative.
Hold on.
Okay, all right, hold on. All right, but doesn't it go, it just goes a different direction.
Exactly. It's in.
But is it a negative?
It could be.
How?
Because, like,
That's
the
some
start
Twilight
point, so
Zone
say you got a
stuff right
start point,
there.
you got the graph, right? You got
Yeah.
a start point, and then if you go left, it's going backwards. So that would be,
Well, here's the deal. If you're in a car and you're in reverse, the miles come off your car.
Yes.
that'll be wrong. That happens.
Oh, that's how it works.
I have a Fitbit
Have you
on.
tried?
All right.
Watch
We
this,
got
guys.
you.
So I have a Fitbit. So how many steps do I have today? I'm over 2,000 steps already. So if I'm walking this way, is it counting my steps?
Yeah.
Yeah, it is. If I go this way, is it taking away my steps?
Yes.
No, actually, this is a really good. Have you guys ever tried to like walk a track and go backwards?
Yes.
It's actually really good. I'll just keep doing this. I'm just keep working on my steps.
Anyway, now when we're talking about segments, like to your point there, Josh, you're right. If you are looking at a graph, if you're looking at a graph itself, and you are trying to, if you move to the left, you do move a negative value, but isn't that distance you're still counting? It's just placement. Okay. It's still a placement, but how far are you away from zero? That's where the absolute value comes into play. Okay. So, what we're looking at here today is we're looking at how far apart things are from one another. And this is the idea that distance can't be negative. And the way that works is because we use what's called absolute value. Okay. Absolute value is how far apart something is from zero. But in our case, we're going to look at number line type style, or eventually we'll talk about some algebra as well. Okay. So the distance between two objects, and this is too long for words. If this is 6 and this is 13, how far apart are they? 7. What'd you do? Or, yeah, what you're doing here is basically you're taking the far away one, subtract the close one, and you get 7. Okay? And that's what you're looking at. Now, it doesn't change if I put this around it. Remember what those uprights stand for? Absolute value. Absolute value stands for distance from 0. Sorry, thank you. Distance from 0. Now, your distance is never going to be negative. So that's why we have it set up with that. Excuse me. If it was this, negative 16 and negative 3, how far apart are those going to be? Negative 16, negative 3. Now, remember, can your distance be negative? No. So what you're looking at here, again, is you're taking the absolute value of how far apart things are. Now, this is kind of weird when you type it all that through. But one of the things that you can do, if you start worrying about your negatives and whatnot, what's nice with these multi-view calculators, if you type in the little negative 3 minus negative 16, it'll give you your answer. It does it like that. Now, Sunshine, you had the older version of the calculator. Yours still works the same way with the negative in there. If you put the negative in, put your negative, oops, the negative 3 minus the negative 16, you still get the same thing. It's just a matter of typing it in correctly. You're a nut job. You know that? Here, use some paper. We don't need Chromebook right now. Yes, sir.
Am I allowed to use my graphing calculator?
Yeah, that's not fine. That's fine. Yep, we won't be doing any, and honestly, we won't do any graphing at all, so you don't need it.
Yeah, my teacher last year.
So that's what we're looking at for this, okay? Segment addition. This is where things start to get more algebraic in terms of with the geometry. Hey, Josh. I have to stop you from doing all the talking, okay? It's getting really disruptive for not just you, for me, for everybody else in the room. So I need you to stop and focus, okay? Thank you. What happens here now is we're looking at something called segment addition. And this is one of the first algebraic rules that we take the step of something that seems really, really easy, and we're just adding it into a geometry context. I was thinking about the word there. Yeah. So we all know that if you're going to go from point A to point B, if point A to point B was, I don't know, 6, and from point B to point C was 11, how far is it from A to C?
11. I mean,
17. What'd you do?
You added 6 and 11.
Yeah, that's all this is.
Well, oh yeah, definitely.
Okay? What happens here is that in geometry, we're talking about it in terms of something with the vocab. Are points A, B, and C on the same line? Yeah, so what are they then?
They're a segment.
What is that called when they're on the same line?
Same plane, co-plane.
Same line.
Same line, you're on the right track.
Co-linear. What he
Collinear.
said.
You're on, I see where you're going, they use opposite rays to create a line, yeah. They're collinear, guys. When points are collinear, close the Chromebook, that's it. When things are collinear, when the points are collinear, all you have to do is just add the two smaller segments together to get the larger one. It makes total sense. You've probably done it before you never even realized it. So what this is that in segment addition, we had, what was it, point A.
Mr. Murphy abbreviates a lot. So that's
That's a seg add.
Basically what this says is that two smaller segments make the large. That's all it is. AB plus BC equals,
ABC.
just AC.
nope.
Start.
Remember, segments use 2 points, a start and an end. And you'll notice that the point in the middle is repeated. And that's kind of like what you were talking about with the whole idea of, like, you were saying opposite rays, and they share that common endpoint. It's kind of the same idea, but in this case, they're not opposite rays, they're just segments that are little joined up together. They have that common spot. Josh, you had a question?
Is AB is the B? Is that the exact middle or no?
No, it doesn't have to be. We'll talk about what's called a midpoint a little bit later on. All right. I try to, it doesn't have to be
It was
skewed
like
to.
a graph that used to be like the middle.
And you're getting ahead here. So what you're talking about is something called a midpoint. If this is a midpoint, that means both of these segments would be the same value. That means it's the halfway spot. Okay. I know it's in this section, but I don't think we'll get to it today. We might just hold off and worry about midpoint tomorrow. All right. Not too bad, is it? Now, just so you know, it's kind of the exact same thing when we get to Thursday. Remember how we talked about this is a what?
Angle.
At an angle. That's a big angle, isn't it? Now, if I take two smaller angles, can't they make a larger?
Yeah.
What do you think that's going to be called?
A cone
If this is segment addition, what do you think that's going to be?
called angle addition.
That's all it is. Math a lot of times is the same thing, just with different shapes, different pieces put together. All right, so when we learn this basic stuff, just adding two smaller to get the larger, it's going to be the same thing with a different diagram. That's all this winds up being, okay? It was really, really, really quick.
Like,
What's that? No, go ahead.
no, I was thinking.
All right. So you get the idea where you can do stuff without the algebra and still have algebra in it, if that makes any sense. You have a whole segment, excuse me, you have the whole segment, well, we have, let's see, FG and GH makes up FH. And I'm trying to figure out what the missing part is. Well, if the whole thing is 36 and the one chunk is 21, what's left over for the other side?
26, 21, that's
15. That's it. And now all you're doing here, all you're doing there is basically this, knowing that if you write it out long form, you know that small segment plus other small segment equals the big segment. Well, if you piecemeal it together with the information that you have, 21 plus something was 36.
Then you just do 36 minus 2.
Yes, sir. What you're creating here is nothing more than a one-step equation, which is, I mean, all you guys know how to do that. That's not tough at all. It's really, really straightforward, okay? Now, they do this in terms of just straight numbers, but eventually we'll also throw in algebra with it as well. We'll throw in the values of x. You know, one segment is 2x minus 3, the other one is 6, and the whole thing is 34, whatever, something along those lines. All right, but it's the same basic premise that all you're worried about doing here is knowing that if you write out what you're starting with, fill in the blanks, everything else is really easy then, okay? Believe me, this first semester, or this first few sections of the algebra that we do, really isn't anything more than maybe a two-step algebra problem, where you have to subtract and then divide, or add and multiply, something along those lines. It's not going to be like you have to worry about factoring and foiling and doing any of that other stuff. It's very user-friendly, okay? Not too bad so far? All right, let's try another one. Oops. So let's rip the Band-Aid off right away. Let's rip the Band-Aid off right away and go right into the algebra of it. Okay, let's go right to the algebra. Now, we have segment addition. We've got 3 collinear points. Oh, let me ask you this real quick. Can you have more than 3 collinear points to do segment addition? Could it be 5 of them if you really wanted to? Yeah, it doesn't matter. As long as they're collinear, segment addition always works. Small chunk plus small chunk plus small chunk will always equal a larger chunk. I mean, it's like measuring this tile and this tile, this tile. You're just adding how many tiles there are, and you know how much they are. Okay. I didn't think you guys would. I didn't think you guys had a problem with that. So write down what you're going to do before you do it. We know that we have the 2 smaller chunks. We know we have EF. We know we have FG. And we know we have EG. And it just kind of replicates itself through. Now, I know that this is an extra step, more a lot, but to be honest with you, these first few days of writing out the algebra, since it's been a while, it's not a bad idea. It really isn't. Okay. And then you fill in the blanks with what you know. Let's see. EF was 8x minus 14. 4x plus 1. And now, sign that up here. And now you're at a combined like terms. What do you got, sir? Well, let's combine like terms first. Don't get ahead of yourself here. I want to make sure everybody else sees that. When I combine like terms, what's my stuff on the left going to look like, guys? 12x minus 13. Good. So the left-hand side, I've got 12x minus 13. Everybody agree with that?
Yeah.
Okay. What do you move first? The 13. How do I move it? Add. Okay. Add the 13 over to the other side. We have 12x to 72. What do you got? How to get 12?
6.
Oh, I'm combining like terms. 8 and 4. 8x and 4x.
6.
You see that? So I might not have said it. Sometimes I go too fast. Does that make sense? It was given to me. It was given to us in the prop. The whole prop. At the very beginning, it was up there. You might have missed it. I'm just making up numbers as I go. And then, when you get to this part, what do you do to get for x? Divide it. What's 72 divided by 12 then?
6.
There you go.
She's been saying it.
sure it's 7.
Okay.
It's like 6.
And
You sound like a grown man.
excuse me. Like I said, this is about as difficult as this stuff gets to start with.
Now, you guys, in algebra, when you got to this point and you got x is 6, were you done?
Yes.
Yeah, you were pretty much done in algebra, right? But now in geometry, we may have,
A lot of times they will ask you specifically, I don't remember what this one said, what are EF and FG? Well, if x equals 6, you'd have to go back and substitute in here and here. That happens all the time in geometry. You just have to read the question carefully. All right, it's very, very, very common. Okay, so in this case here, you substitute in the 6. 6 times 4 is 24. 24 and 1 is 25. And then the other one would be 48 minus 14. What was that? 30. Okay? That's what we're looking at doing here, guys. Very systematic, very straightforward. Write down what you have and fill in the blanks.
This stuff easy.
Okay.
This stuff hard.
We'll get there.
We need to get into like the hundreds.
It's a what?
We need to be like 122 times x minus like 7.
All right. Take a minute. Take a minute and try these two, please. Second one we go through.
Can I do it?
Well, just for the sake of time, add them together. Let's see, we got 2x, a 3x minus a 1. So we have 5x and a 2. We get 5 for x, I'm hoping? Yes. All right. You get 5 for x, and then it asks you to solve for yz. 15 minus 1 is?
14.
There you go. All right.
20. No.
Ah. Remember I had I think this might be our last example that I talked about today. Yesterday, or earlier on, I asked you if it's possible to have more than one point going through and setting up the segment addition. This is a really good example of how that looks. Okay? This is a really good example of how that looks. Now, in this case here, you've got points P, Q, R, and S that are collinear, which means they're all in the same line. No big deal. It tells you that the whole thing is 46. The small chunk of PR is 18. And then it says that PQ and QR are the same. Now, when two segments are the same, have the same value, same length in geometry, we say that that is called congruent. So if the whole thing is 46, this chunk is 18, and those two are the same. What does that make those two smaller segments?
One big segment.
A
number.
Yeah, good.
I was thinking each point.
Yeah. Now, what happens here, guys, is that you will be able to do some very quick mental math to get that far. Okay? The only segment we don't know just by looking at that quick setup is what? I think it's just RS. Okay. Well, if you look at it, RS is the whole thing. PR is the one chunk. So what would I do to figure out what RS is then? What do you get? A number. Very good.
Wow.
Now, from there, did you notice that I never even once looked at one of the questions?
No.
That's what happens a lot of times in geometry. Geometry, we're going to get problems that have multiple parts to it, that it's much easier just to go to the diagram first, fill in as much information as you possibly can before you try to answer any questions at all. It makes your life easier. Okay? Because now you can go back and say, oh, PQ. PQ is 9. QR, oh, that's 9. QS, well, that's 9 and 28. That would be 37. And then RS, we have is 28. That's what you want to be able to do in geometry. Whenever you see big picture style problems where they're asking you multiple questions, ignore the questions until you fill in what you can on the diagram. It makes everything easier. I mean, there'll be a time later on, when we get to some of the circle stuff, there's some problems that you'll have, 7, 8 questions on just one part. But it's a matter of just filling in a little bit of the information at a time to help you figure it out, okay? It's a huge, huge thing in geometry. And blah, blah. All right, because I think the next bit goes into midpoints. Yeah, we'll stop here. We'll pick up midpoints tomorrow, okay? Let me give you... Yeah. No. Now, let me look at the book here real quick. I'm Bless you. All right. This is the assignment. Bless you. Ladies and gentlemen, this is the part on here for the homework. Now, there are going to be, I think there's a few questions on here that talk about midpoint. I'm going to figure out what numbers they are real quick for you guys to go ahead and just skip them for now. We'll probably have time to do them in class tomorrow. But I figured with only having about 8-10 minutes, I don't want to jump into that too far. So let's see. On 24, 9. Yeah. All right, so here's what I want. Just that. We'll worry about midpoint and the rest of it tomorrow. All right? Just do those. Don't put it down the actual back. A lot of times people put it on just on the cover, and they forget that people just steal the cover and take it like this. All right. Yeah, just do those for tonight. We'll change it up and finish out midpoint tomorrow. There's a couple of terms. Yeah. If you guys want, hey guys, if you want, here's the actual textbook. If you want to just take a picture of the book here. No, this is my book. We don't have this book, but if you want to take a picture of it, it's right there for you. Yes, ma'am.
I'll say it. No, I'm not.
We will. Yo, what's up?
I'm ready to go. I'm ready to go.
Same afterwards.
Take a nap.